Welcome to reInvent 2020. My name is Vasily. I'm based out of Luxembourg in Europe. I'm the specialist solution architect focused on storage. And the major topic for today I'm going to cover during the session is security best practices with Amazon Elastic File System, Amazon EFS. What is that? In short, EFS is NFS, Network File System in the cloud. NFS is a well-known protocol. It evolved during the last 36 years, and nowadays it is simple but rock solid in perspective of reliability, perspective of performance and security protocol. But EFS is not just NFS, it's much better because we are doing our best to make it feature-rich, to make it cloud-native, to integrate it seamlessly with other cloud-native services like serverless functions or containers. And we are doing our best to make it even more reliable and cheaper comparing to on-prem NFS solutions. NFS is simple, as I said, and if you are curious, you can check it by yourself. For example, you can execute your favorite packet capture application and check the whole protocol stack, starting with RPC, remote procedure calls, next with XDR, the presentation layer, and NFS protocol itself. And you will be able to see how we send and receive read and write data, how we mount NFS, how do we set and adjust security settings. But before we mount EFS, of course, we need to create a file system and we need to create a set of mount points. So we have to create a mount point in different AZs, availability zones. And next, you are able to mount these EFS storage resources to virtual machines in the same subnet or in different subnets or even from on-premise. So you can use your Linux servers based on in your data centers. And of course, EFS is a cloud-native solution. That is why it is used as a permanent storage for services like ECS, Elastic Container Services, both in Fargate and based on EC2 machines, EKS, Kubernetes in the cloud, of course, Amazon AWS Lambda, and machine learning services like SageMaker. So, of course, the major topic for today is security. And in formal perspective, there is a shared responsibility model. And according to the shared responsibility model, we, as AWS, as Amazon Cloud, we are responsible for security of the cloud. And you, as a customer, you should take care about security in the cloud. But of course, security is our priority number one. And of course, we are trying to do our best to provide you as much as possible features to help you to secure your EFS storage in the cloud as well. That is why I'm going to go through the set of best practices, the set of advices, how to improve your EFS security. And of course, I will start with NFS native things, the common things usually we use with NFS. And next, I will proceed with advanced features like control network access, how do we encrypt data, how do we enforce user identities, and how we can use IAM, identity and access management policies, to control your access to EFS file shares. And I will start with the basic things. How do we control file and directory access based on POSIX permissions? Yes, NFS is a POSIX file system. That is why, of course, it works with users and groups. I do believe you remember this magic acronym, UGO, which stands for users, groups, and others. And of course, we set permissions for writes, so reads, execute, based on users and groups, ownership and membership. And nothing special here. Of course, I'm not going to go deep into POSIX permissions. Everybody knows about that. But I'd like to highlight two things about EFS. First, we always work with numbers, with numeric UIDs and group IDs. So EFS has no clue about actual usernames. And when you mount EFS from different, virtual machines, let's say, and you are using the same user, let's say 5001 user ID, in perspective of EFS, it would be the same user. It doesn't matter what we did with the name of the user, it would be the same user because its number is the same. And when user ID and group ID provided by NFS client, by your Linux machine, is always trusted by Amazon EFS. EFS as NFS service does not check and is not able to check your permissions. So it just accepts and trusts you. It is a basic thing. It is about, general NFS access, but we offer you much more features outside of, standards NFS functions. And one of them is when we can enforce user identities and root directories. As I already explained you, so users use their user IDs and group IDs, and they are taken by EFS server as is. But we can use a very great feature, which is access point. And configuring access point, you can override UIDs and group IDs provided by NFS client. For example, we configure access point with the user, POSIX user Alice. And actually, it doesn't matter if, for example, Bob will decide to create a file. Yes, Bob will create a file. In standard situation, Bob would be the owner of this file. But with access point will override permissions, and even when Bob created this file, Alice would be actual owner of this file. Really great feature. Another thing is when we enforce root directories. What does that mean? Actually, when we create a EFS file system, we can create a structure of different folders. Folders for Alice, folders for Bob, any other users' folders, and using root directory. We can configure access points pointing, for example, to Alice's directories. And when we mount these access points, users will be able to see nothing outside of the structure of folders specified, the Alice's folders specified in the access point. They will not be able to see folders, those belong to Bob. They will not be able to see structure upper in the hierarchy of folders. So really great thing. So what is next? Next, I'd like to discuss how do we control network access with EFS. And yeah, you remember when I explained how do we configure EFS, I mentioned that the key point is to create some number of mount targets in every availability zone. And the good news is mount targets are just simple ENI, elastic network interfaces. What does it mean? That means we can apply security groups. We can apply these firewalls on top of ENIs. So simple. And this feature allows us to control access in networking perspective. Which IPs or IP ranges are able to get access to your EFS. And even more, we can use other security groups. We can specify if some clients are members of specific security groups, and they are described in your target security group, you can allow access based on security groups as well. So, next topic is about data encryption. And I'd like to start with data encryption in transit. So, EFS is NFS-based service. That means, of course, we can use standard Linux commands to mount your services. So that's okay. But the best practice, the best approach, of course, to use EFS mount helper. EFS mount helper is nothing more but orchestrator, which just helps you, which simplifies different options to mount your EFS resources. For example, just with one parameter, TLS minus or TLS, you can specify as a mounting parameter. You can say to NFS client to use STUNL, to use encrypted TLS 1.2 tunnel, and to send and receive data encrypted with TLS. So simple. So I do recommend you to use mount helper with in-transit encryption option. It's a theory actually, but I always trying to test it. So I never trust. I always trying to prove if it's true or not. And so what did I do? Just a few days ago, I created a file system, and first I mounted this file system without encryption. And next I wrote something into a file. And you see, I can read this data. If I can capture packets, I can read this data. Yeah, that's obvious. What is next? I remounted this file system with TLS encryption enabled. And now, yes, I can realize it is NFS traffic, but nothing more. I cannot see inside the traffic. I cannot see any data. So that means it works. Great. So let's proceed with data at rest encryption. So I said data at rest encryption, but important to remember, to understand, actually we are talking about both data and metadata. We do encrypt both data and metadata with AES 256 algorithm. And the great thing is, it's totally transparent for your applications. You literally you need to do just nothing with your applications. Everything would be encrypted and decrypted back automatically. That means it's free of charge for you. It's free of charge in perspective of money, and it's free of charge in perspective, redeveloping of your applications, or even in perspective of performance penalties. That's a really great feature, and why not to use it? Next, I'd like to proceed with IAM policies, identity and access management policies. But before I will go deeper into different ways how do we use IAM policies to secure EFS, I'd like to remind you few things, because I am quite complicated thing, yeah? I'd like to start with the magic acronym, magic word, EPARC, which stands for E, effect, allow or deny. P stands for principle. It is about who is going to get access, either user or group, or you assume a role with this policy attached to it. Action is a specific action if you'd like to create a file system or maybe allow read-write access to specific users. Resources. What is resource? Resources are EFS file system. It's obvious. And conditions. C stands for conditions. Different conditions we apply to specify the special cases when we allow or deny something. One more thing. It's about policy evaluation logic. Of course, I'm not going to go deep into that. It's not really complicated, but the major thing I'd like to highlight here is, by default, everything is denied. That means implicit deny is always the case. You shouldn't forget about implicit deny. And when we configure EFS policies, IAM policies, of course, we widely use implicit deny rule. When we are talking about IAM, in general, yeah, it's kind of complicated thing. It's very powerful, but you need to know and remember about identity-based policy, resource-based policy, trust policy, SCP, service control policies, how we assume roles, and a lot of things, of course. But for EFS, you should remember only two things. The first one is we are using identity-based policies. The policies, those apply to users, groups, or when you assume specific role. So the principle is obvious. That's why P letter, principle, is not needed in the policy. And the opposite situation when we apply this policy to our resources, our EFS file system. That is why resource is obvious. So we don't need to specify resource. So simple. So we have identity-based policy and resource-based policy. And these policies, these both approaches can work together. And the resulting permissions are the total permissions of both resource-based and identity-based policies in the same account, guys. So it's important. I'm talking about same account. If we are trying to reach your EFS in different account, the picture is slightly different. But in the same account, there is a potential situation when, for example, in resource-based policy, we are using implicit deny to control access, but this implicit deny will be overwritten by explicit allow, which we are using on the level of identity-based policies. Maybe it sounds complicated, but don't worry. So I will give you a few examples and everything would be much, much clearer. So let's start with control API access. So what we are talking about? We are talking about how do we control, management functions. And of course, we have predefined policy. We can start with read-only or full access. With full access, you are able to create file system, delete file system, update file system, and of course get some information about existing access points and so on. Read-only is read-only. You cannot modify it. I do recommend you to use predefined policies, but in some cases, of course, you need to use customer-managed policies. Maybe in some cases, you need to create your own policies on more granular level controlling access to your management functions on with your EFS file system. Next, I'd like to discuss a very interesting topic. How do we control client access based on IAM policies? And I already said, so we have two major things we play with Django. The first one is resource-based policy. Let's start with it. Yeah. We can configure, there are plenty of different ways to configure resource-based policy. And the easiest way to use predefined options. For example, we can control if root have access, or we enforce encryption of the file system in transit and so on. But of course, there are plenty ways to specify custom-made policies. Let's start with simple case, anonymous access. What does it mean, anonymous? Anonymous means it's not identified as a user or group or role. It is the case for your servers on-premise. Of course, on-premise there is no IAM as a service. And when you connect your Linux machine from on-premise to the cloud, of course, it's considered as anonymous. Or another case, when your EC2 machine, you execute EC2 machine, but you didn't specify any particular role to it, or you didn't assume this role. So it will be anonymous as well. So in this case, we should specify P, ePark, you remember, P principal as, start, just say everything. And next you can manage with different actions. Do you remember about implicit deny? In this specific example, we say explicitly we allow client mount only. That means everything else is implicitly denied. We are not able to write, because when we specify cloud mount, we can only mount and read data. We are not able to write data. Okay, let's consider a couple of other examples. For example, we have EC2 machine and we assume role. We have two roles. We consider two roles. The first one is semi-trust and another one is full trust. Yeah? So when we assume this role, we can manage access on different levels. So for example, for semi-trust, we can explicitly allow client mount and client write. That means, so all the clients, all the users with user ID not equal 0 will be able to read and write our data. But the next example provides us even more rights in security perspective, because we explicitly allow client root access. We allow client mount, client write, and cloud root access. In this case, everybody who assumed this specific full trust role can read and write, including root. So let's consider another very, very common and really best practice way to use IAM policies. So I'd like to talk about access points. Access points, as I already mentioned, is really powerful feature which allows you to provide, allow or deny access on very granular level. And by default, in this case, because of implicit deny, direct access to our EFS file system will be forbidden. Yeah? But when we define a condition to specific access point, we can allow all users, all NFS clients mounting our EFS resources via this specific access point to read data if I'm using client mount, for example, as an action. Or you can read and write and to use other actions as well. It's really, really great way, and do recommend you to use access points and use this IAM policy as an example. We discussed resource-based policies, but of course we can use identity-based policies as well. So we can just create your policy. You need to attach this policy to a role, and next, on the client level, on the customer level, you need to assume this role. For example, when you assume this role on EC2 machine. So, do you remember? One of the advices was, please use EFS mount helpers. Why? Because it's so simple. It's so simple to manage different things with EFS mount helpers. For example, to assume IAM role, you just need to specify IAM mount option. That's it. So simple. Come on, please use it. So, a couple of more examples. The first one is about reinforcing encryption in transit. When we on the level of resource-based policy, we specify that we allow, and in condition we say secure transport through. That means nobody who does not enable TLS encryption will not be able to read and write data, and mount, of course. And the second example is about how do we reinforce encryption at rest. For example, we have a group of administrators responsible for creating new file system, deleting file system, and so on. It's so simple to apply to attached policy with condition encrypted true, and these guys will never be able to create file system without at-rest encryption enabled. Yeah, it works on the whole account level. Yeah, so great. Of course, when we are talking about security, we also think about how these security features help us to be compliant with different regulations. You know, HIPAA, GDPR, I'm from Europe, of course, GDPR, PCI DSS, high trust, CSF, and many, many others. So, of course, we are compliant with a lot of regulations, and if you need more information, I do suggest you to check the documentation. Summary. Let's summarize what we talked about. So, EFS, of course, EFS is a really, really great service. It's NFS in the cloud, but it's not just NFS in the cloud. Actually, it provides features. It's a feature-rich service which provides features those allow us to make our access to our storage even more secure, much more secure, using control network access, encrypting our data in transit and at rest, when we enforce user identities, and when we using IAM policy to control API access or control client access. Yeah? And if you ask me, so what are the four major takeaways we need to remember after this session? I would say the first one would be access points. It's really, really great and powerful thing. I do suggest you to use access point even if single application per file system is used, because it gives you very granular, very powerful level of control. The second thing is always control network access with security groups. It's easy. It's a common way. It's a very AWS cloud native. Everybody knows how to use it. Yeah, just use it. The next thing, you remember, I already mentioned, encryption is free, both in transit and at rest. It's free in perspective of money, it's free in perspective of performance penalty. Why not to use it? Just use it. And the last but not least is, I do believe that access, when you control access based on IAM policies, identity and access managed policy, really help you to restrict and control access to in-cloud resources. EFS is really powerful and popular AWS service. And of course, during reInvent, we offer you the whole set of different sessions. So you can find something new about how to improve performance, cost, how you can integrate EFS with containers or serverless functions. So please look through the list of sessions and yeah, check it out. So that is the end of my presentation. Thank you very much for your attention, for your participation, and as a friendly reminder, please complete the survey, the session survey. So it would be great to hear your opinion about EFS security and about this session. One more time, thank you very much and all the best.